Yeah, I think we still have 5 minutes and then we can wait for more to join us and then we can start. Also for delivery format, I just want which one do you prefer? So we have three options. Either have the class offline in the classroom. We have one classroom assigned for this course. It's at a main hall 115, if I remember correctly. And we can either have this one online, via Zoom. Then we can do a presentation online via Zoom. We can also have discussion via Zoom as well. The third option, probably we can have it as hybrid. The presenter can come to a classroom, give the presentation, then the student audience can attend the presentation either online or offline. I'm not sure which one do you prefer. And we would plan to have a pool probably at the end of today's lecture, then we can decide the format for delivery of this course.
Hi, Professor. Just a quick question about the attending physically in the class. If we go to the classroom, and will you still record your lecture and post online?
If we go to a classroom, then I will also be attending offline, and then I have no access to the Zoom anymore, and the student will be the presenter instead. I'm not sure if I can record or not, or the student can help me record this one, then we can post online. It depends on the presenter.
Oh, okay. Because what I want to say is, like when you give the lecture, or say when you give the feedback, and if that can record it and answer question and answer this kind of things, and they'll be recorded online. So when we go back and review the paper or review the content, so we can directly go to the Zoom and see the video first. And otherwise, the question may be asked again, and it's kind of waste time on both sides.
That's true. If we do the hybrid, then there will be some miscommunication problems. We exist. And we can decide the format maybe after the approval first, then we can decide how to solve these problems according to the choice you prefer.
Okay.
I see one question in the chat. Do we have plan to expand the class? And it seems someone are on the waiting list. So right now, the university or the department set aside to be 50 for this course. The 50 is already very large for this course because we have a very small number of papers to be presented. Probably right now, we don't have plan to further expand the class size because 50 is already very large. Before when I teach this course, I prefer to have a very small size class, like 10 or 20 students. Then each student can present 1 or 2 papers alone. Right now we have 50 students already, then we have to do the presentation in groups instead. So it is already very large and we don't have plans to further expand this course. But probably after the first class, then you can check some of the students probably will join this course because this one is based on seminars, right? Someone expect this one to be an actual course. Then student will be joined this course and you can, if you are on the waiting list, you can probably come in, remove from the waiting list and come in and register this course instead. And we will see, what will happen in the coming weeks. I expect some of the students will join this course, because this one is different from what they expect actually. Okay, so maybe we can start, and someone else probably will also join us during the class. And we can first start, then we can see, then we can finish all the lecture today. So first of all, welcome everyone to the ECS 289G on advanced deep learning. It seems in the registration system, this course is on AI. Actually, this course is on advanced deep learning. We plan to create a similar course on deep learning to discuss the latest papers published in the last year. So for students. And here is some basic information for the course. So the course number, title, and the units. Please check your system. The unit will be full actually. And the course date, time, the classroom. We have one offline classroom assigned, which will be at the Wayman Hall and 115. And we also have this online Zoom meeting classroom created as well. We will have one poll at the end of today's class to see how we plan to deliver this course for you instead. Okay, so you may also wonder why we plan to create this course. We know this course will be a seminar course on advanced deep learning research. The main reason is because deep learning nowadays is changing so fast, and all the traditional lecture-based courses cannot deliver the latest development of the techniques of deep learning to students anymore. That's the reason why we plan to deliver this lecture based on seminars. So you can see my shared screen, right? Okay, so this course is mainly created for the PhD students as well as senior graduate students who are working on deep learning research. And this course will also be very different from other courses in the computer science department you have ever taken. The main reason is because for this course, a student will be the main role, and you will be the presenter for many of the papers we plan to discuss in class. And we plan to divide the students into different groups and to give the presentation of the papers and also do a discussion and QAs to discuss some potential opportunities for research on deep learning. We plan to cover the latest papers which are published in 2021 and 2022 about deep learning in the last year as well in this year for you. And then you can know what is happening outside in academia nowadays. Also, to be honest, this course is not easy. It will be very difficult according to my previous experiences. So if you don't have sufficient background, you can get lost very easily when we read papers or discuss about papers. It's not easy. Also it will be very math heavy. We will see many papers with lots of formulas, lots of math equations. So you need to have sufficient math backgrounds as well to understand the papers we discuss in class. The workload will be heavy. We have tons of readings because we have lots of papers to read before class, and we also have lots of presentations. We have no homeworks, we have no exams, but we have one quarter project on a paper. So by the end of this quarter, the student need to write a paper, on research about deep learning actually. So if you don't have any previous experiences on paper writing, then it will be a problem for you because you have to finish a paper from the beginning to the end and from scratch. According to the communication with some of the students, it seems some of you don't really know deep learning and plan to learn it based on this course. And my feedback, probably this one is not the right option for you to start with. And if you know, I'm not sure if you know or not, we have another course created. It is called ECS 189G. This one is for the introduction to deep learning for the students. And you may consider to take the ECS 189G first if you don't know deep learning right now. We will provide you with a comparison between two courses, then you can decide which one is a better match for your backgrounds. So for the ECS 189G, I just teach this one in the winter quarter, and we have finished it already. This course is created for the undergraduate students as well as graduate students. For the backgrounds of the students, we assume you don't know deep learning right now and plan to learn it for your project or for your job hunting. And we plan to provide you with lots of lectures to covering all the basic deep learning models. If you see, it covers very broad topics in the course actually. In the very beginning, we can discuss about some optimizers like gradient descent, SGD, mini batch GD, momentum, adaptive gradient descent, as well as add-on. These are all the optimizers we can use for training models. We also cover some basic deep learning models like multi-layer perception, the autoencoder, the variation autoencoder, CN, NXNet, VGG, ResNet, and GAN. And besides them, we'll discuss some other models proposed for sequence data like recurrent neural nets, LSTM, GRU, transformer, and BERT. And we also cover models for dealing with graphs with deep learning, GCN, GAT, GResNet, GraphBird. And we also have some discussion for the application of deep learning for specific topics like computer vision, natural language processing, and graph learning. So you see, this course will be probably a better option if you plan to learn deep learning and you don't need it right now. And this course is based on lectures, and we have like 10 weeks of lectures to discuss about these topics for you, to introduce what are the models we discuss here, we mention here, and how to use these models for applications. So the main objective for the ECS 189G is to teach you basic and the classic as well as new deep learning models, and also to help you get familiar with programming with PyTorch. The delivery for this course will be some projects on deep learning applications with PyTorch. So this one is probably a bit easier one for you to start with if you don't know deep learning right now. And let's come to the ECS 289G, this course we plan to have in this quarter. So this one is called Advanced Deep Learning. We create this one for the PhD students as well as senior graduate students who are interested in deep learning. We assume you know deep learning very well already and can also write and publish papers already as well. So as to the topics covered in this course, we will cover all the latest research papers which are published in the last year as well as in this year about deep learning. So to be honest, if you don't know deep learning, then you will get lost very easily because some of the papers, they're not easy actually. They're very difficult to read and also present. And this course will be based on seminars, and we have the presentation for each class, and we discuss one paper, one class per class. And we will go over what is happening in academia in the last year for the students, and we expect the student can deliver a formal research paper by the end of this quarter, on deep learning, based on paper we discuss in class. So you can see these two courses are created for different objectives and for different students, depending on your backgrounds and also your expectations. You can register both either one according to your requirements. So I will teach both of these two courses in every year, and I teach this ECS 189G in the next winter again, and also this course again in the next year. So you can decide the order to take which one first and which one next, according to your backgrounds. So let's see, the ECS 189G will be offered again in the next year. Normally offer this ECS 189G in the winter quarter. And I also see a question, audit, yes, I think it's offered in the, So we offer this course in the winter quarter. So when I talk at the same time, I also see the chats at the same time to see your questions. So I will stop sometime. I also offer both of these two courses every year. This one is for the winter quarter. This one is for the spring quarter instead. Normally, I hope you can take this one first and then come to the ECS 289G. It will be easier for you to follow the papers we discuss in class. And let's come back to the course. So we have created one course website for the ECS 289G course. And you can check out this course by clicking this link. Generally, it covers all the things about this course. Covering the syllabus, announcements, policies, schedules, slides, project, and resources. So please make sure you check this course website periodically and if you have time. Also read the course syllabus of class, policies, and lecture schedule, and you can also ask me if you have any questions. So for this course, we have no discussion session, and we have a TA, and we also have office hours from both the instructor as well as the TA. So if you have any question or unclear parts, you can attend office hours with both the instructor and TA to get your question resolved. So the teaching staff, I will be the instructor for this course. And actually, I will be the instructor for the first class only, and then you will be the presenter for the remaining classes. So here is my email address. And my research is focused on AI, including machine learning, deep learning, data mining, and big data. We have also delivered this course in the previous years before as well. So according to my experiences, it seems it will be very helpful for senior graduate students who are working on research about deep learning. Then you can capture what is the trend right now on deep learning and do research. We also offer office hours online and via Zoom just after class on Monday. So you can talk with me if you have any questions or unclear parts for the course with me. We also have one TA assigned by department, Xiao Liu, and he is a graduate student in the computer science department. And he will help me grade many of the submissions as well as the presentations for you. And I will be the main grader for the final paper instead. He will also offer the office hours via Zoom on Thursday, in the afternoon, during 2 to 3 p.m. on Thursday. So depending on your availability, you can either attend office hours with me or attend office hours with a TA, depending on the time you have. Okay, so these are basic information I have for the course. Then you tell me why you plan to take this course. We all know deep learning is very popular nowadays, and lots of people want to learn deep learning for their job hunting, for your project, for your research. And this page, I also prepare some of the videos to share with you about deep learning, about AI, about data mining for you. So you can see, find some motivation why deep learning will be very important for the future. So probably we can share the videos together in the class, and it will be very short actually. So the first video we have is about the Alphago actually we have in the past years.
Go is the world's oldest continuously
Can you hear the audio or not?
played board game.
Yes, we can hear it.
One of the simplest and also most abstract.
Beating a professional player at Go is a long-standing challenge of artificial intelligence.
Everything we've ever tried in AI just falls over when you try the game of Go.
The number of possible configurations of the board is more than the number of atoms in the universe.
Alphago found a way to learn how to play Go.
So far, Alphago has beaten every challenge we've given it, but we won't know its true strength until we play somebody who is at the top of the world, like Lee Sedol.
Like no other is about to get underway in South Korea.
Lee Sedol is to Go what Roger Federer is to tennis.
Just the very thought of a machine playing a human is inherently intriguing.
The place is a madhouse.
Welcome to the DeepMind Challenge. The whole world is watching. Can Lee Sedol find AlphaGo's weakness? Whoa. Is there, in fact, a weakness?
The game kind of turned on its axis.
Look at his face. That is not a confident face.
It's developing into a very, very dangerous fight.
Ooh, hold the phone. Lee has left the room.
In the end, it is about pride.
I think something went wrong. Yeah, it's made a mistake. It's got to be a miracle.
These ideas that are driving AlphaGo are going to drive our future.
This is it, folks.
So they also have a movie release, on Alphago. You can check the movie as well if you are interested. So, this Alphago is from DeepMind. Actually, in this year, for the papers, we also have a paper from DeepMind on Alpha. It's called Alphago, if I remember correctly. And they have a new paper coming out, which can write code by the model itself. It's another big breakthrough, in deep application of deep learning for the programming of the software engineering. Besides this video, we also have two other videos on deep learning prepared for you as well. We can share with you at the same time.
Ever wondered how Google translates an entire web page to a different language in a matter of seconds? Or your phone gallery groups images based on their location? All of this is a product of deep learning. But what exactly is deep learning? Deep learning is a subset of machine learning, which in turn is a subset of artificial intelligence. Artificial intelligence is a technique that enables a machine to mimic human behavior. Machine learning is a technique to achieve AI through algorithms trained with data. And finally, deep learning is a type of machine learning inspired by the structure of the human brain. In terms of deep learning, this structure is called an artificial neural network. Let's understand deep learning better and how it's different from machine learning. Say we create a machine that could differentiate between tomatoes and cherries. If done using machine learning, we'd have to tell the machine the features based on which the two can be differentiated. These features could be the size and the type of stem on them. With deep learning, on the other hand, the features are picked out by the neural network without human intervention. Of course, that kind of independence comes at the cost of having a much higher volume of data to train our machine. Now, let's dive into the working of neural networks. Here, we have 3 students. Each of them write down the digit 9 on a piece of paper. Notably, they don't all write it identically. The human brain can easily recognize the digits. But what if a computer had to recognize them? That's where deep learning comes in. Here's a neural network trained to identify handwritten digits. Each number is present as an image of 28 times 28 pixels. Now, that amounts to a total of 784 pixels. Neurons, the core entity of a neural network, is where the information processing takes place. Each of the 784 pixels is fed to a neuron in the first layer of our neural network. This forms the input layer. On the other end, we have the output layer with each neuron representing a digit with the hidden layers existing between them. The information is transferred from one layer to another over connecting channels. Each of these has a value attached to it, and hence is called a weighted channel. All neurons have a unique number associated with it called bias. This bias is added to the weighted sum of inputs reaching the neuron, which is then applied to a function known as the activation function. The result of the activation function determines if the neuron gets activated. Every activated neuron passes on information to the following layers. This continues up till the second last layer. The one neuron activated in the output layer corresponds to the input digit. The weights and bias are continuously adjusted to produce a well-trained network. So, where is deep learning applied? In customer support. When most people converse with customer support agents, the conversation seems so real. They don't even realize that it's actually a bot on the other side. In medical care, neural networks detect cancer cells and analyze MRI images to give detailed results. Self-driving cars. What seemed like science fiction is now a reality. Apple, Tesla, and Nissan are only a few of the companies working on self-driving cars. So, deep learning has a vast scope, but it too faces some limitations. The first, as we discussed earlier, is data. While deep learning is the most efficient way to deal with unstructured data, a neural network requires a massive volume of data to train. Let's assume we always have access to the necessary amount of data. Processing this is not within the capability of every machine. And that brings us to our second limitation, computational power. Training a neural network requires graphical processing units, which have thousands of cores as compared to CPUs. And GPUs are, of course, more expensive. And finally, we come down to training time. Deep neural networks take hours or even months to train. The time increases with the amount of data and number of layers in the network. So here's a short quiz for you. Arrange the...
So they can provide with some basic information about deep learning. I assume you have those already, and they can provide some background knowledge if you don't know deep learning yet. Besides this, we also provide with a short video from some famous people about their opinion for the future of deep learning and AI. And we can also share this one in class.
Google, Facebook, Apple, Microsoft are all moving ahead at a great speed in improving this artificial intelligence software. So it's very exciting. Software is going to solve that, where it'll look at all the new information and present to you, knowing about your interests, what would be most valuable. So making us more efficient.
We're focusing on what we've talked about on autonomous systems. And we sort of see it as the mother of all AI projects. So autonomy is something that's incredibly exciting for us. We'll see where it takes us.
Wouldn't it be wonderful if someday we got to the point where there were robots every place, they were running farms, they were running Apple, they were running Berkshire Hathaway, and all you had to do was one person could punch a button at the start of every morning, and all the goods and services that we're getting now would be turned out by robots.
It is seeping into our lives in all sorts of ways that we just don't notice. We're just getting better and better at it, and we're seeing that happen in every aspect of our lives, from medicine to transportation to how electricity is distributed. And it promises to create a vastly more productive and efficient economy. And if properly harnessed, can generate enormous prosperity for people, opportunity for people, can cure diseases that we haven't seen before, can make us safer because it eliminates inherent human error in a lot of work.
Artificial intelligence is going to be extremely helpful, and the risk that it gets super smart. That's way out in the future and probably worth talking about. But now what we're seeing is that for the first time, computers can see as well as humans. That's pretty incredible.
NHTSA did a study on Tesla's Autopilot version 1, which was relatively primitive, and found that it was a 45% reduction in highway accidents. And that's despite Autopilot 1 being just version 1. Version 2, I think, will be at least 2 or 3 times better. That's the current version that's running right now. So the rate of improvement is really dramatic, but we have to figure out some way to ensure that the advent of digital superintelligence is one which is symbiotic with humanity.
AI is probably the most important thing humanity has ever worked on. Now, I think of it as something more profound than electricity or fire. And anytime you work with technology, you need to learn to harness the benefits and while minimizing the downsides. You know, stepping back, when you think about a lot of problems in the world today, it's because we typically have a constraint on resources. AI, for the first time, I think over time, offers a different construct. Things which are constrained and look like a zero-sum game today may not be so in the future. Take education, for example. It's really difficult to educate people in a cost-effective way. AI may fundamentally change that equation. It may make it possible for us to have clean, cheap, renewable energy for the future. So I think a lot of things will play out in more positive ways than people think.
I think probably by end of next year, self-driving will encompass essentially all modes of driving and be at least 100 to 200% safer than a person by the end of next year. We're talking maybe 18 months from now.
The idea that there's going to be a general AI overlord that subjugates us or kills us all, I think is not something to worry about. I think that is overhyped. First of all, we don't know, we're nowhere close to knowing how to build a general AI, something that could set its own objectives. But second of all, I think it's unlikely that such a thing's first instincts would be to exterminate us. So I'm optimistic about that one and certainly don't think we need to worry about it today.
Okay, so this is some of the opinions from the CEOs of many big companies. About deep learning and AI for the future. You see, generally in the future, lots of companies they are investing lots of money resources into deep learning and AI, and they also create lots of products, lots of services for the people based on deep learning as well. So no matter what you plan to do for the future, you can either become an IT expert on some hedge fund companies or some Boeing companies, or you plan to be a system developer at Google, Amazon, or you want to be a data scientist or machine learning scientist at Google and Facebook and Uber, or you want to be a researcher at Microsoft Research or IBM Research, or you want to become a professor exploring deep learning and computer science in the future. Then I think AI deep learning can be a very promising direction for you to explore in the future. So also, we see lots of examples of application of deep learning in the real world. Besides Alphago we mentioned before, we also see many of the other applications of deep learning in real world services now in Amazon. If you ever search some products in Amazon, then this website can also provide you with lots of recommendations of similar products or some other products you would be interested in, and they can provide you with some recommendations shown here, then you can buy them. Besides the recommendation in Amazon, we also see this kinds of application of deep learning in search engine as well as with Google. If you type in some keywords, they can provide with web pages contains keywords and also provides with ranking. So right now, Google, they also adopt deep learning into their search engine as a component as well. Also for the Tesla and the self-driving, it's very popular nowadays. We also have some papers prepared for this course on self-driving cars as well. So you can see how can we do the self-driving and based on the sensor system we have with the cars. So there are lots of applications of deep learning in the real world already. Then we can discuss some new potential opportunities for the future by discussing about papers we have in this class, in this course. Also, you may wonder what makes deep learning success nowadays. And so the success of deep learning actually comes on 3 main factors: on the hardware, on the big data, as well as on the deep model architectures. So we know nowadays deep learning training relies on the GPUs a lot. If you plan to train a larger deep learning model, you have to buy a GPU and also train the model with like a more powerful computational platforms like HPC or cloud computing platforms instead. Also, deep learning relies on lots of data for training. So in other words, we have to use lots of data, connect lots of data for training the models. At the same time, we also need to design the deep model architecture for the model to be more effective in the future. So in this page, we show you with a comparison of different GPUs sold by NVIDIA, in terms of the computational power. I'm not sure which one do you have. Actually, the first GPU I have ever purchased is a GeForce GTX 1080 Ti. At that time in 2017, it's very powerful. However, when it comes to today, it's very low actually. It's very slow compared with some other GPUs we have. Right now, my group just purchased another GPU, it's the RTX A6000. It's much more powerful than the 1080 Ti we have before. I'm not sure if you have ever seen the news article from NVIDIA. They have a new version of GPU. It's called H100. H100 GPU is very powerful than the A6000 we have here. So the GPU, this computing power is increasing a lot nowadays, and I think it will keep increasing in the future years, and we can see have more and more powerful GPUs coming out. Also, the deep learning success relies on the big data. We see lots of data coming out almost every day. In this page, we show with some numbers, about data we can have in every minute. Now, for example, we can have the traffic data we have in 1 minute on the internet is about 6,000 TB. And for the Google searches in every minute, there will be about 6 million searches in Google, now more than 100 billions of emails sent in every minute. Also, the data is increasing very fast. According to the chart we have seen at the bottom side, the size of data will be expected to grow to more than 170 ZB by the end of 2025. So the big data can serve as a fuel for training the deep learning models. Because of the availability of big data, then we can train very powerful models out nowadays. Also, the success of deep learning relies on the algorithm or not. So we see we have different models designed already, by researchers in both in academia and industry. So we also see lots of toolkit coming out by the companies like PyTorch from Facebook and TensorFlow from Google coming out. It makes it much easier for the researchers to develop some new algorithms on deep learning. So in this course, you also need to do some projects with apply the PyTorch or TensorFlow to implement some new algorithms on deep learning for the paper as well. And you also need to run the model on some data sets to get the results and report into the papers. Also nowadays, the model we have now is very big actually. In this page, we show with the size of models we have nowadays about deep learning. And this one about the transformers. I'm not sure if you know this or not. In the 2018, we have the GPT coming out, which is proposed by OpenAI. And that year, GPT is very powerful. It has about 110 million parameters. In that year, I'm not sure if you remember it or not, it's a very big model actually. However, when it comes to the 2020, we have GPT-3 coming out. The GPT-3 had more than 175 billion parameters. And when it comes to last year, we have 3GC from Google coming out. It has more than 1.6 trillion parameters coming in the model. So you see the model size is growing very fast nowadays, and we will need to build more powerful computers to train the models. So for comparison, we also show the number of neurons we have in the brain of human brain, all the number of synapses we have the brain for comparison. So according to some report for the human brain, we have more than 100 billions of neurons, and we also have more than 1,000 trillions of synapses. So compared with the number of parameters we have in the deep learning model like 3GC, the number is comparable to the human brain statistics already. So in the future, we expect the model will growing larger and also faster, and sometime we have a model which is larger than the human brain coming out. So this is the factors which makes the deep learning successful nowadays. And we also show you the industry of deep learning nowadays. Lots of companies, they are investing into deep learning. So as we mentioned before, the success of deep learning relies on many factors, the hardware chips, the platforms, as well as the algorithms. So many companies, they are making some new chips coming out, almost every day. So we have new GPU from NVIDIA. We have new Tensor processing unit from Google. We also have some new CPU from Qualcomm, from Intel, from AMD as well. Besides the chips and hardware, many companies are also investing into building the cloud computing platforms. Like we have Google Cloud, we have AWS, we have Microsoft Azure. They all provide the computational platforms for us to train larger models nowadays. At the same time, we also rely on the algorithms, all the frameworks. We have the PyTorch from Facebook, we have TensorFlow from Google, and many companies, they are making the toolkit for the researchers, for the practitioners to make new models come about deep learning nowadays. So based on this kind of hardware and platforms and the algorithms, we can make lots of algorithms coming out to solve the many real-world problems. So we have different solution providers. I mean, these companies, they can provide solutions for different areas at the same time. So now the majority of the countries, they are investing into AI and deep learning for the future. Now, the US and China, they are the major investors. We also see that Japan and South Korea and also many countries from Europe, they are all investing into the future for deep learning and AI. So according to my experiences, I think the deep learning will be one of the main trends for the future in the industry. We will show you the revenue size estimated for the future years about AI in the coming years. According to a report, I mean, this revenue, the market size is growing very fast. According to a report, by the end of 2025, this market size will be growing to $35,000 million by the end of 2025. So we see that in the industry, it's a very promising direction for the future because lots of companies are investing in this area, and also the market size is growing very fast. At the same time, in academia, we also see lots of researchers make lots of achievements due to their contribution to AI and deep learning. In 2018, we have Turing Award, which is given to 3 researchers due to their contributions of AI and deep learning. I assume you know this already. Also, according to the report, I mean, for the submission to major conferences in recent years, we also see a surge of number of submissions of the papers published in major conferences, like CVPR and NIPS. So for me, actually, when I started my PhD program in 2012, at that time, it's relatively easier to publish a paper at major conferences. However, nowadays, publish a paper at a top conference is becoming much harder nowadays. So I think depending on which one you plan to work for, either industry or academia, I think deep learning is a very promising direction for it to work on in the future. Okay, this is some background knowledge for deep learning, and let's come back to this course. So the main objective for the ECS 289G, we create this course to have the students update about the latest development of deep learning in the past year. We plan to select about 20 papers published at the top tier conferences in the last year and also in this year. We will have a series of presentations about these papers and also with discussion about these papers with some potential opportunities for research. Besides the presentation, we also plan to help the students to design and implement some new models on deep learning, because we will have one project which is for the research papers. So we will have 1/4 paper from researchers, from students on potential research problems based on the papers we discuss in class. So you have to decide your research problem, also design a new model on deep learning based on the papers we discuss in class, also implement the model out with the experiments on the real world data sets. And you also have to write the paper out as well for this course. So you see, I mean, for this course, we have both the paper reading presentations. We also have one paper writing for the project as well. So we have some requirements for student background. So you need to have backgrounds about computer science in terms of data structure, discrete mathematics, and algorithms. You have taken some prior courses before. At the same time, I also hope you have no deep learning already. I mean, you need to know basic deep learning models like CN, GAN, recurrent neural nets, LSTM, transformer, BERT, GCN, GAT, because many of the papers we plan to discuss are based on these papers, based on these models. At the same time, I also hope you know how to implement these models with PyTorch, TensorFlow already. Then you can do the paper and the projects very successfully. Besides this, we also hope you have listed math backgrounds in terms of some basic calculators, linear algebra, or some statistics and probability theory. If you also know some like mathematical optimization, it would be much better. So you can train the model with no problem. We also hope you have very good programming skills, also paper writing skills. And we have one project. You have to both implement the model with PyTorch or TensorFlow with Python. So it will contain lots of programming work for the project. At the same time, you also have to write a paper based on that tag after you finish the project. So you can check if you can meet these requirements for the course, and then you can decide if you can take this course in this year or in the next year instead. So for the textbook, we have no required textbook, but we have one recommended textbook instead. So the recommended textbook is on deep learning. This one is an ebook. It's free, so you can download the book from this web page, and you don't need to buy it. We also have 2 other reference books for your information. You don't need to buy it if you don't have them. And if you have the book in hand, then you can check these books as well as you read the papers in this semester, in this quarter. Okay, and then let's come to the format of this course. So this course will contain lots of paper reading, also paper review. In each class, we will discuss one paper. In each class from the presenters. Also, before the class, the student need to present. The student need to read the paper before to be presented in class. Also, each student need to write a paper review report to be submitted to the camera system. So the review report will cover many main factors: a summary for the paper, 3 strong points for the paper, 3 weaknesses for the paper, as well as some potential ideas for the future works, and some other questions you may have in mind when you read the paper to be asked to the presenters in class. And the student need to submit the review report before class to the camera system. We'll provide you with template, which is this link. You can check this link for the template for writing the review report. Besides the paper we discuss in class, we also have some other reference papers prepared for you as well. And for these external reference papers, you don't need to, we don't plan to present them in class, and you can read them by yourself after class, and you don't need to write any review report for them either. As for presentation, so the student can form a group. The next slide will be 4 to present a paper in class. And if you are the presenter for a paper, then you don't need to write a review report anymore for the paper you present. As to the presentation, the length will be about 1 hour. It will cover many main factors: the background knowledge of the paper, the problem studied, the definitions, the ideas, and the proposed method and techniques, experiments, as well as the results of the paper, and some other works related to the paper, and some other potential future works for the paper. So if you have very short or no coordinate presentations, then we will have some points graded from your grade. And if you copy the existing presentation or slides from the web, then it will be treated as a plagiarism. Additionally, we also have about 20 minutes for the Q&A and discussion with the audience, among the class. So the student can ask a presenter with some question you have in mind for the paper we discuss in class, and you can also share the ideas if you have any in mind for some potential opportunity for the future. So if you are the presenter, then you have to send the slides to the TA before your presentation day. In other words, if you are, for example, if you do the presentation on Wednesday, then you have to send the slides to a TA by Tuesday midnight. This is for the presentation. And for the project, we have 1 quarter paper to be finished by the end of this quarter. So the student can form a group to work on project on the paper. The slide will be step 4 to make sure, to make it easier for us to grade your presentation as well as the project. We hope you can have the same members for the group if you plan to do the project and the presentation groups. The member will be the same for both the presentation and the project. So each group will need to finish an independent research paper for this course based on the problem we discussed in class on deep learning. And the paper will be original work, though recycled, published, or submitted paper or ongoing paper with some other faculties or classes. And at the middle of this quarter, we will have a proposal to be due, which will be, mainly describing how you plan to write the paper. So you need to cover a proposal, that covers the problem to be studied, the rough idea of your model, as well as data set to be used for your paper, as well as the planned experiments for the paper. So next will be about 2 pages following the ACM template. And by the end of this quarter, we also have you need to submit 1 paper to the camera system, which is the final paper for the course. The next will be 10 pages following the ACM template. We will provide the link for the ACM template in this page as well via this link. So the paper will be graded according to the novelty, the technical depth, the completeness, as well as the research values. So grade will be deducted if we have seen very low quality or incomplete papers for the project. Okay, then let's come to the presentation slides. So we have prepared some papers for you to present in class, which is via this link. We can share this one with you. I mean, we can click this one and go to the page. So I think many of you have ever checked this paper already. I mean, this paper is already. So we divide the papers into different topics about deep learning, about computer vision and images, about natural language processing and text, and about graph neural nets, recommended systems, and robotics. So depending on the area you're working on for your research, you can choose the paper to present in class. So for the first two classes, since many of you will job or join in this course, so we ask some of the students to do the presentation in the first 2 weeks. Then you can choose from the remaining papers to present in class, I mean, according to the one you like better. So for the papers we discuss in class, some of them, they are longer, some are shorter. So like for the first two papers we plan to discuss in class, they're very long actually. So the first one is to combine the visual models with some language processing signals. This paper is very long. It has about more than 40 pages actually. So I hope you can check the papers first before you read these papers. And you can check the paper first, I mean, to see the topics, to see the contents, to see if you can present them or not. And to the second one we plan to have in the next week will be for the Alphago. This one is very famous from the DeepMind in this year. So we also plan to discuss this paper in class and to see what we can do based on this Alphago as well. So generally you can check these papers, the topics and the title to see if you know the paper or not. Then you can retrieve these papers to present in class. As to the way how to register these papers, so we do the registration based on first come and first serve rule. And if you like some paper, you can contact the TA for reserving these papers. Once the paper is reserved, you cannot change them anymore in the future. As to how to register the paper for the presentation, so first of all, you have to find your teammates if you plan to do the presentation and the project in groups. So the next slide for team will be 4, and we'll create a Discord group link, I mean, for you to find some teammates. If you want to find some other teammates, you can just join the group and write some posts there to find some other members who are also looking for the teammates as well. Also, I mean, if you have formed teams, then you'll be tied up for this quarter and for both the presentation and for the project paper. And members in the same team will receive the same grade for the presentation and the project. If anyone leaves this course or leaves this team, then the remaining will pick up the job instead. If you plan to register a course and also you have found your team already, then you can submit one team form information to the Canvas system based on the report we provide here. So you can complete this report and by typing all the necessary information and then submit it to the Canvas system and notify the TA to register the paper for you instead. We can check this report for you and it covers necessary information for the team, your team name, as well as the members in the team. So the next slide will be 4. If you plan to do the project in the presentation by yourself alone, you can also do so, and then you can delete the remaining lines in this form instead. Or at the end of the form, you have to end the paper you plan to present in class, then you can ask TA to register the paper for you instead. So once you have submitted this form to the Canvas system, then you can notify the TA to register the paper according to your report. And the TA will help you type in your name into the slots in the skill spreadsheet based on the first come, first serve rule. And if your preferred paper has been reserved by someone else before your group, then you may have to talk with the TA as soon as possible to reserve some other papers instead. As to a grading policy, I mean, so we divide the grade into different parts for the presentation, for the course participation, and the project of the paper. So the in-class presentation will be about 30% of the grade. If you copy the existing presentation slide from the web, will be treated as a plagiarism, and later submission of the slides will be not accepted. And the grade will also be deducted for some short presentations, not less than 15 minutes for the presentation. To the course of participation and QA, so we will require the student to submit one report for the paper we discuss in class before the class starts. Also, during the class, the presenter audience will have a QA and a discussion about the paper we discuss in class, and later paper review report submission will not be accepted. All the grade will be deducted for low class appearance. As to the project, we have 2 parts for the proposal and the final paper. So the proposal will be due by the mid of this quarter, and the final paper will be due by the end of this quarter. it will take a 10% and 50% and 40% respectively. Depending on the points you can get, then you can decide the final grade according to the table we showed at the bottom part of this page. So we also have a summary for the submissions and the deadlines. So first part will be for the review reports. It is based on the individual submissions. Each student need to submit one report to the camera system before the class. So the submission will be to the camera system. We have created a link to you already, and you can upload the report to the camera system. Also for the printing slides, I mean, if you are presenting for the Wednesday, then you have to submit the slides to a TA via email before your presentation. So it will be due before the day of your presentation, and it will be submitted to the TA via emails. We only require one single submission for one group. So if you have multiple members in the group, you can maybe find one leader for the group and ask him to submit the reports or slides. Similar for the project paper, and we also require only one single copy of the submission for one group. And we also have some deadlines. The first part for the team formation for both the presentation and the slide and the project, it will be due by the April 8th by the midnight. You have to finish the report, to upload to the camera system by the time. Also by the middle of this quarter, we have to ensure the proposal will come in by the April 29, which is the mid of this quarter. And at the very end of this quarter, we will have the final paper to be due by the June the 3rd of this quarter. Always the report will be submitted to the camera system for the project and for the team formation, for the proposal, and for the papers. But generally, that's for this course. And as to the delivery format, as we mentioned before, we plan to have this course online, but depending on your preference, we can have 3 different options. And we plan to have a pool instead for the delivery format. The option 1 will be, we can have this course purely offline in the classroom, which will be at the Main Hall 115. Another option, we can have this course purely online via Zooms. We can have a discussion via Zoom, which will be probably easier for us to discuss. The third option will be a hybrid. We can have the presenter to give the presentation in the classroom. As to the audience, I mean, you can decide either to attend the class via the Zoom or by attending the class offline instead. So I'm not sure which one you prefer. So we can create a pool to see, which one you prefer by voting instead. Let me create a pool for you so you can decide the one it works better for you. Can you see the pool right now? And then you can click the one you prefer. Has everyone voted? Okay, then we will end this voting. So according to the voting result, you can see the voting results, right? According to the voting result, it seems the majority of the students will be favor the online class instead. So I'm not sure if this one will work for you or not. Then probably according to the voting result, we can have the class online instead for the quarter if it works for you. Is that okay for you? Or if you have different opinions, then you can share with the class instead.
Excuse me, Professor, we can't see the results of voting.
You cannot see the results?
Yeah.
Let me share the results with you.
Yes, it works now.
Okay. So you see, about 25 students were voting for the online, and we have 7 for the offline, and then we have 20 for the hybrid. So my plan, maybe we can do this course online, for the quarter, if it works for you. And if you have any special requirements, like you prefer to present offline, then we can also arrange this one as well for you as well. I mean, for the remaining quarter. Okay, so probably that's it for general rough information for the course. I just wonder, do you have any question right now? We have shared with you the basic information for the course already, and for the course format as well as the material to be discussed. So please let me know if you have any questions.
Yeah, hi, Professor. I have a question for the final paper. You said we need a 10-page long paper to submit. And how much like complete you expect for this 10-page long paper? Is like everything should be done, the experiment and well right, and all the grammar is perfect and everything is perfect to submit in for this 10-page, or it's okay to have a briefly draft for this 10-page long paper as long as the design is good? Because I think it was in 10 weeks. It's not quite easy to get a good paper for that.
So we expect you can have a paper as complete as possible. I'm not sure for you, right? If you do the research intern in some complex, normally the intern will be about 3 months, and you have to finish one paper for the internship, right? For the research internship. It will be very similar for this course. We expect it will be sufficient for you to finish one paper in 10 weeks. I mean, you need to finish the problem study as well as the model design and do the experiments. So, I mean, we hope the experiment will be as complete as possible, covering the major results as well as some other case studies and some other results as well. So you can try to finish this paper as complete as possible. Then we can decide this later.
Okay, thank you.
Yeah, any more questions?
Hi, Professor. I had a question on the final project as well. Is it necessary that it be on a sort of a new architecture that we design, or is it sufficient to sort of use a pre-existing architecture, but in a new setting or on a new task?
So the question is about the paper. So it will be either brand new paper, I mean, on brand new model on a new problem setting, or it will be an application of some existing models on a new problem setting, right? So the answer is depending on your preference. So you can either do a paper, which is for the applications. You can apply the model to a new setting or new problem and then do the paper. This is one way to write paper, to do research, right? Or you can design new model architecture to study some new problems. It should be also okay. Depending on which one you prefer, we have no requirements for this part. You can do the one, it works very easy, better for you, I mean, according to your research backgrounds or your projects.
Thank you.
Yeah, any more questions? So to be honest, this course will be not that easy. If you prefer to find some easy course to get a high grade, probably this one will be not the right option for you. You have to devote lots of time, lots of efforts to this course, then you can learn something useful. And I offer this course every year. So if you think you're not ready yet in this year, then you may consider to take the ECS 189G first, and then retake the 289G in the next year instead. It will be probably easier for you to get started. I mean, if you have the background of deep learning already, then you are welcome to, take this course to discuss the paper with us. So it requires you to do many jobs. I mean, you do the readings, do the presentation, also do the paper writings. So it's very tough, to be honest, for this quarter. Yeah, so please let me know if you have any more questions. And you can also send me emails if you have any questions. I mean, we can also host office hours after today's class if you have any unclear parts. So by the way, I mean, in today's, on the Wednesday class, we will discuss one paper, which is for the visual model. So for the presentation Wednesday class, we will have the paper discussing about learning transferable visual models from the national supervisions. So this paper is very long. I hope you can read the paper before class and you can start this paper reading as soon as possible. It will take lots of time for reading the paper. And the presenter will be Sean Liu. He's also the TA for this course, and he will give the presentation for us about this paper. And if you have any question when reading the paper, you can also ask the presenter during the class, and then we can have a discussion. If you have no question, then probably that's it for today's class. And thanks a lot for your attention and time. If you have any question, you can always ask me or either attend my office hours to discuss with me.
Professor, are you going to share the slides with us through Canvas?
I have shared slides already in the spreadsheet. You can find slides here in this column. And for the remaining presentation, we also share slides in this column as well. So by posting by the TA as well.
All right, thanks.
Yeah, any more questions?
Hi, Professor. I have a question.
Yeah, sure.
First of all, do we have to form a group for the final project?
It really depends on you. So we allow you to form a group for the presentation and for the project. And some of you probably prefer to work in groups with someone else. Then if so, then you can form a group for the presentation and for the project. At the same time, if you prefer to do the presentation by yourself alone and do the paper writing by yourself alone, then it should also be fine for me. You can work on all the projects and presentation by yourself instead.
I see, but if like the group is just a one-person group, does the scope allow to be like smaller, like the problem scope allow to be smaller than the group one?
So if the group is smaller, then we take this into consideration when we're grading the final presentation and the final paper for you.
I see. So second question is that is it allowed to use my current like lab project to be the class project?
So according to the requirements, I mean, this paper should be some original work, no recycled, published, or some maybe ongoing works with some other faculty or classes. So you can start the same problem you're working right now with a new model instead. Then you can write a new paper, right? I don't recommend you use some recycled paper from some other projects for this course.
I see, but if this paper is just the paper I'm working on right now, is not published yet, is that allowed?
So this one will be ongoing work, right? It will be not allowed actually.
Oh, I see. Okay, thank you.
You can start the same problem, but you can propose a new model instead for based on the model we discussed in class for the paper. That should be fine. Right? Yeah.
Understand. Thank you.
Okay, so any more questions? Okay, so if you have no questions, then that's it for today's class. And if you have any more questions on clear process, you can send me emails or attend my office hours, then we can have a discussion about it. Okay, thank you for your time and attention. Bye-bye.